Hello dear students, myself Shraddha Punda, lecturer in Electrical Engineering Department, Kekewak Polytechnic, Nasik. I welcome you all to my educational video channel. In this video, we will discuss about phasor representation of an alternating quantity. So let us begin with it. First, we will see what is phasor. Phasor is a straight line with an arrow marked at its one end. The length of the straight line represents the magnitude of sinusoidal quantity which is being represented, and the arrow represents the direction. Here you will see the simple phasor. The phasor is a straight line having an arrow at its one end. This length represents the magnitude and the arrow represents the direction of rotation. So the phasors are assumed to be rotated in anti-clockwise direction. One complete cycle of sine wave is represented by one complete rotation of phasor. So here you will see the one cycle of that particular alternating quantity, and this is what the phasor rotation. The direction is in anti-clockwise and the speed at which it rotates is angular speed, which is measured in radian per second. Let us see what is phasor diagram. A phasor diagram is used to show the phasor relationships between two or more sine waves which are having the same frequency. So we can represent the two quantities through the same phasor, but what we want, the both quantity have the same frequency. Now let us have look for concept of phase of an alternating quantity. The phase of an alternating quantity is defined as the divisional part of cycle through which the quantity moves forward from a selected origin. When two quantities have the same frequency and their maximum and minimum point achieved at the same point, then the quantities are said to have in the same phase. So here you will see the quantity has been advanced and it moves forward from a selected origin. So that particular uh, is the phase of that quantity. Consider the two alternating currents IM1 and IM2 which are shown in the figure. Both the quantity attains their maximum and minimum peak point at the same time, and the zero value of both the quantities establishes at the same instance. So you will see over here both currents having the same zero position. They are reaching their maximum value at the same time as well as the minimum value. So these two quantities, that is Im1 and Im2, are said to be in phase. Let us have look for the phase angle, which is represented by theta. The equation of induced EMF in the conductor is given by V equal to Vm sin theta. We can further write it as V equal to Vm sin omega t. In the above equation, the theta is called as the phase angle, which is the angle made by the conductor with the reference axis. Now moving towards phase difference, which is denoted by phi. It is not necessary that the two voltages or current waves they originate at the same instant of a time. The phase difference between the two electrical quantities is defined as the angular phase difference between the maximum possible value of the two alternating quantities having the same frequency. In other words, the two alternating quantities have the phase difference when they have the same frequency but they attain their zero value at the different instant. The angle between 0 points of the two alternating quantities is called as the phase difference. So here you will see the phase difference phi between the two quantities. The quantities are originating from their zero position at different times. Now we are having two phase differences. One is the leading phase difference and another is lagging phase difference. Let us consider the equation V of A equal to Vm sin theta and Vb is equal to Vm sin theta plus phi. If the phase difference phi is positive in the equation number 2, then it is said to be a leading phase difference. In other words, we say that VB leads VA by an angle phi. So here you can see the voltage is the leading quantity which leads current I by an angle phi. So that is the shown in waveform as well. Voltage leads current by an angle phi. Now lagging phase difference. Again consider the two equations. VA is equal to Vm sin theta and VB equal to Vm sin theta minus phi. If the phase difference phi is negative in the equation number 2, then it is said to be a lagging phase difference. In other words, we say that VB lags VA by an angle phi. So the same is shown in the phasor representation, where you will see this is the reference axis and current lags voltage by an angle 30 degree. So the same is shown in the waveform. Here the voltage lags current by 90 degree. Now let us see what are the in-phase quantities. The two alternating quantities, they are said to be in a phase when the phase difference between them is 0. That is, the value of phase difference is equal to 0. Let us have the two equations, V equal to Vm sin theta and I equal to Im sin theta. Then the phase difference between them is 0 and the two quantities are said to be in phase. Here we are having the two waveforms for the voltage and current, where you will see they are originating from the same 0 position and they are having maximum value at the same time. So these two quantities are said to be in phase because the phase difference between them is 0. We can represent it through phasor diagram as well. So these two quantities are said to be in phase. Now let us have look for the out of phase. The two alternating quantities are said to be out of phase when the phase difference between them is 180 degree. So the phi value is equal to 180 degree. So you will observe in the waveform that two quantities are out of phase, and by phasor representation we can show the two phasors which are making the angle between them, that phi equal to 180 degree. Let us have mathematical representation of phasor. Any phasor can be represented mathematically in two ways. One is the polar form and second is the rectangular form. Let us see first what is polar form. Consider the equation I equal to Im sin theta plus phi. The above alternating quantity can be represented in its polar form as r at an angle phi, where r is equal to the maximum value of that quantity. For multiplication and division, we want the quantities in a polar form. Let us have look for the rectangular form. Consider I equal to Im sin theta plus phi. The above quantity can be represented in rectangular form by the rectangular form x plus jy, where x is Im cos phi and y is Im sin phi. Or it can be written as x equal to r cos phi and y equal to r sin phi, where r is equal to maximum value of that quantity. So for addition and subtraction of phasors, the rectangular form is suitable. Let us have summary what we have discussed in this video. Graphical representation of phasor. What is phasor? Phasor diagram. Concept of phasor. Phase angle. Phase difference. Lagging and leading phase difference. In phase and out of phase quantity. Mathematical representation of phasor. Thank you for watching my video.